Welcome to Math Vision Tutorial. My name is Moses. Today we shall be talking about Coulombs Law. Coulombs Law is talking about the force between two charges Q1 and Q2. And the force between two charges Q1 and Q2 we call the force an electric force or the Coulomb force. So now what does Coulombs Law state? Coulombs Law states that the electric force F between two charges Q1 and Q2 is directly proportional to the product of the magnitude of the charges. That is, the magnitude of Q1 multiplied by the magnitude of Q2. And it is inversely proportional to the square of their distance r apart. So that is Coulombs Law. Please take note of that. Let's consider the first figure here. We have two positive charges, two like charges. The first charge we call it Q1, the second charge we call it Q2. The two charges are separated by a distance called r. They are separated by a distance r apart. So now, notice that the first charge Q1 is exerting a force F1 on Q2 in the direction to the right. It's trying to push Q2 away from itself. While Q2 as well is exerting a force F2 on Q1 to push Q1 away from itself. Notice the direction of the two forces, F1 and F2. They are opposite in direction, but the two forces are equal in magnitude. And the magnitude of the two forces is given by Coulombs Law. So let's consider the second figure over here. We have two unlike charges, the positive charge and the negative charge. The first charge as well, we call it Q1. The second charge, we call it Q2. They are both separated by a distance r apart. The first charge Q1 also exerts a force F1 on Q2 and Q2 exerts a force F2 on Q1. Notice the direction of the two forces. Q1 is trying to draw Q2 closer to itself and Q2 is trying to draw Q1 closer to itself. They are trying to attract themselves. Unlike the first figure they are trying to repel from one another. So from figure 1 and 2, we have that like charges repel while unlike charges attract. So now, charges are fundamental like mass. They are independent. They are very fundamental. They are independent. They are mostly denoted as Q, uppercase Q or lowercase q. They are measured in the unit called coulombs. The unit called coulombs, C. And they are really small in magnitude. Charges are really small in magnitude. Example, 10 raised to the power minus 14 coulomb. Imagine how small 10 raised to the power minus 14 is. It's 0.000000. So they are very small in magnitude. Example is 10 raised to the power minus 14 coulomb, 10 raised to the power minus 6 coulombs, and so on. So from Coulombs Law, we have that F is directly proportional to the product of the magnitude of Q1 and Q2, and it is inversely proportional to the square of their distance apart, that is 1 over r squared. So now multiplying the numerator over here, we are going to have that F is directly proportional to product of Q1 to the product of magnitude of Q1 and the magnitude of Q2 over r squared. So now from our high school, doing variation, introducing the constant of proportionality, which we are introducing any constant, we introduce k to change this sign of proportionality to equality. From here we have that F is equal to k multiplied by the magnitude of Q1 multiplied by the magnitude of Q2, everything over r squared. So now, where k is called the Coulomb's constant, and k is equal to 1 over 4 pi epsilon naught. And 1 over 4 pi epsilon naught is approximately equal to 9 times 10 raised to the power 9 Newton meter square per coulomb square. Please take note of this constant because you have to know this constant offhand. So now, note that the electric force or the Coulomb force F is a vector quantity. Yes, it is a vector quantity because it has magnitude and as well it has direction. And its magnitude is given by F equals to K multiplied by the magnitude of Q1 multiplied by the magnitude of Q2 over R squared. This magnitude of F is given to us by Coulombs law. So now let's look into some examples under Coulombs law. Now we are on example 1. Calculate the electric force between 2 point charges of 10 microcoulomb and minus 20 microcoulomb separated by a distance of 25 centimeters. From the question, we have two charges given to us. The first charge is a positive charge, which is 10 microcoulomb, and the second charge is a negative charge, which is minus 20 microcoulomb. This negative sign is to tell us that the second charge is a negative charge, while the positive sign for the first charge is to tell us that the first charge is a positive charge. But when we are talking about the magnitude of the charges, we are not going to consider their sign. We are just going to take them as positive. That is the magnitude of the charges. But the negative sign and the positive sign is to tell us the kind of charge which they have. So now, let's look at the solution for the first question. By Coulombs law, we have that the force, the electric force, is given by K multiplied by the magnitude of the first charge multiplied by the magnitude of the second charge over R squared. So now, the value for our constant, which is K, we already know that to be 9 times 10 to the power 9 Newton meter squared per coulomb squared. And our first charge is 10 microcoulomb. And micro is a prefix. It means 10 to the power minus 6. So we can rewrite this as 10 times 10 to the power minus 6 coulomb. But the magnitude, like I explained, the magnitude will still be 10 times 10 to the power minus 6 coulomb. That is the value for the charge. So now, Q2 is minus 20 microcoulomb. This minus 20 microcoulomb can still be written as minus 20 times 10 to the power minus 6 coulomb, because micro means 10 to the power minus 6. So now, taking the magnitude of the second charge, we have it to be 20 times 10 to the power minus 6 coulomb. We do away with the negative sign. We are only interested with the magnitude now. So we have it to be 20 times 10 to the power minus 6 coulomb. And the distance R between the two charges is 25 centimeters. The distance between the two charges is 25 centimeters, and we have to work in meters, the SI units. So we are going to convert this to meter. And how do we do that? This C, which is centi, centi means 10 to the power minus 2. So we just convert this centi to 10 to the power minus 2, and this is 25 times 10 to the power minus 2 meters. So now, the electric force from the formula, we just put in our values into the formula. The value for K is 9 times 10 to the power 9. And the value for the magnitude of the first charge is 10 times 10 to the power minus 6. And the value for the magnitude of the second charge is 20 times 10 to the power minus 6. Everything over the distance square. The distance now is 25 times 10 to the power minus 2 meters. Then this will be 25 times 10 to the power minus 2 or square. Then, pressing this on your Casio scientific calculator, you have that the electric force is approximately equal to 28.8 Newton. That is all for the first question. And if you are asked to tell the nature of the force, the nature of the force will be attraction, because the first charge is a positive charge and the second charge is a negative charge. They are unlike charges. So the nature of the force will be attraction. They will tend to move towards each other. So the nature of the force for this first question is attraction. So now let's look at the second example. The second example said, the proton and electron of a hydrogen atom is separated by a distance of approximately 5.3 times 10 to the power minus 11 meters. Calculate the magnitude of the electric force between the two charged particles. Now, by Coulombs law, we know that the electric force is given by this, by Coulombs law. Now, and the value for our constant is 9 times 10 to the power 9 Newton meter squared per coulomb squared. And the proton is Q1. We take it as Q1, which is the first charge. The value for the charge of a proton is a constant, and the constant value is 1.60 times 10 to the power minus 19 coulomb. You have to know that offhand. Taking the magnitude will still be 1.60 times 10 to the power minus 19 coulomb, because the positive charge is to tell you that a proton is the positive sign is to tell you that a proton is a positively charged particle. and the electron is a negatively charged particle. They have the same magnitude, but they are opposite in signs. So that's why we have that electron 2 is minus 1.60 times 10 raised to the power minus 19 Coulomb. But when you take the magnitude of Q2, it will just be 1.60 times 10 raised to the power minus 19 Coulomb. You will do away with the negative sign. So now, the distance between the two charges as given in the question is 5.3 times 10 raised to the power minus 11 meter. It is already in meters, so you just have to leave it like that. Then this is 5.3 times 10 raised to the power minus 11 meters. So we go into our formula and put in all the values one by one. So don't forget to take note of this value. It is a constant value. You have to know it offhand. So now our K is 9 times 10 raised to the power 9, and the magnitude of the first charge is 1.60 times 10 raised to the power minus 19 coulombs. The magnitude of the second charge is 1.60 times 10 raised to the power minus 19 coulomb over the distance between the two charges, 5.3 times 10 raised to the power minus 11 all squared. Then putting this in your Casio scientific calculator, you have that the final answer is 4.35 times 10 raised to the power minus 18 Newton. And that is all for the question as well. So if you are asked what is the nature of the force between the proton and the electron, don't forget that proton and electron are opposite charges. So the nature of the force between them will be attraction as well, because unlike charges attract. So now let's look at the third example. The third example says, what will happen to an electric force F if one of the charges is doubled, 2, the distance is tripled. Now we already know the formula for the electric force. The formula for electric force as given by Coulombs law is F equals to K multiplied by the magnitude of Q1 multiplied by the magnitude of Q2 over R squared. So how do we know what will happen to the force if one of the charges is doubled? Now, what does it mean to double something? To double means 2 times of the thing. So now, let's consider any of the charge. Let's consider any of the charges. We can consider the first charge, we can consider the second charge. But considering the first charge, if we double the magnitude of the first charge, which is Q1, it means 2 times of Q1. So doubling Q1, we are going to have K 2 times magnitude of Q1 times magnitude of Q2 over R squared. We have doubled one of the charges now. And this, we can rewrite this as 2K magnitude of Q1 magnitude of Q2 over R squared. We just make rearrangements here. We haven't altered anything there. We just make rearrangements by writing 2 before K and magnitude of Q1 magnitude of Q2 over R squared. So now, don't forget that this over here is the force, which is F. So we just write this as, and this will now be equal to 2F. So after I doubled one of the charges, I have the result to be 2F. It means after doubling one of the charges, the first 2 will double by 2. So the first 2 will be doubled rather. So this means that F2 will be doubled, that is 2 times F. After doubling one of the charges, then the first 2 will be doubled. So now, the second one, what will happen to the force if the distance is tripled? Now, initially, our force is K multiplied by the magnitude of Q1 multiplied by the magnitude of Q2 over R squared. So now, if I triple the distance is in the denominator. To triple means 3 times. So if I triple the distance, I'm going to have it as 3R. But don't forget that the distance is carrying a square. So this will be 3R all squared. And by indices, I have to distribute this square to the 2 of them, and this will be 3 squared multiplied by R squared, and the result in the denominator will be 9R squared. But this expression over here, I can rewrite it as 1 over 9 multiplied by K multiplied by magnitude of Q1 magnitude of Q2 over R squared. And this over here is equal to our F. And this we are going to have this to be 1 over 9F, which will be equal to F over 9. This means that the electric force will decrease by 9. That is after I tripled the distance. After I tripled the distance, what will happen to the electric force? what will happen to the electric force is that the electric force too will decrease by 9. So now I have some practice questions for you to solve, and if you have any questions concerning the class, you can drop it in the comment box below. These are the practice questions. There are just 2. The first question now is, what will happen to an electric force F if the first charge is doubled, second charge is tripled, and the distance is doubled? Now the question is, if these 3 things happens, what will happen to the electric force? So now the second question goes thus: the electric force between 2 positive charges of magnitude 5 microcoulombs and 12 microcoulombs is 100 Newton. What is the distance of their separation? That is, what is the distance of separation between this 5 microcoulomb charge and this 12 microcoulomb charge? Please endeavor to solve these practice questions. And if you have any question or any problem concerning this class, concerning today's class, you can please drop in the comment box below. And please subscribe to my YouTube channel and click on the notification bell to get notified whenever I drop a new video. And don't forget to like, share, and watch the video. See you in my next class.